Hello everyone and welcome to week 6 of Exercise Physiology for Sport for the Master's Degree program at Concordia University. We are now halfway through our classwork here in the fall semester of 2018 and now we're talking about chapters 11 and 12 of our Exercise Physiology text with acid-base balance and temperature regulation. That said, being just past the halfway point, it's a good thing if things have been challenging for you, and hopefully it's disappointing. I understand if it's not disappointing. It's a class, probably for many of you like any other class, but the hope is you're still getting a lot out of this. I'll still do the best I can to keep you as interested as possible, to keep you involved as much as possible, so you do get the most out of it. And that said, a few concepts to kind of talk about from week 5 and the previous weeks, getting continual clarification, which should never stop. I've said this before and I'll say it again, none of this stops. I have to keep looking over the same textbook chapters myself every time I go over them to make sure I'm covering material clearly, getting better than the previous time I taught, just like you need to get each practice more planned and more clarity in each practice for each game preparation you're actually going through for every athlete or for your team each time. We all have to keep getting better, right? Now, clarity in work and rest periods and intensity. From a work period standpoint, if you're going to say we're going to do blank drill, we're going to do lunges, we're going to do some medicine ball throws, we're going to do some skips, some jumps, whatever you say you're going to do, give me the work period. Don't just say, here's the drill. I have this picture in my head of someone doing this drill in the way that I see it, but more importantly, the mechanically, what's going on, every movement biomechanically, which is more towards biomechanics, although important, and movement skills vital. Certainly, I want to know the work period. What's your work period? And as soon as you say work period, you can bet what I want to know next. What's the rest period? If you say the work period's 10 to 20 seconds or 10 to 15 seconds and you say it's 95% intensity, and then you have a 30-second break and you say 5 sets or 10 sets, it's not 95% intensity. It can't be done. It's not possible. We talked about how the rest period needs to be at least 90 seconds to gain back 90+% ATP. Maybe longer, maybe 3 to 5 minutes. So make sure that you're clear when you talk about work period, you better understand the rest period too. The textbook even refers to ATP, adenosine triphosphate, creatine phosphate being the excuse me, primary energy system for football because it's a sport that's less than 10 seconds, but it says for the first play. It doesn't say ongoing, that's your primary energy system, because the book, they understand that if the rest period's only 30 seconds-ish, all depending upon what's going on between plays, how much time there really is when they restart the clock, all that, then it may not be, and it's not going to be for those players that are continually on the field and repeatedly playing a key role in each play. It's not going to be adenosine triphosphate, creatine phosphate. It's going to move towards glycolysis and eventually toward aerobic oxidation if they stay on the field and keep breaking for 30 seconds. So it depends on a lot of factors, the work periods and the rest periods. That's why I want you to be clear about that. And of course, intensity. When you say intensity, I want you to be clear about it. You're talking about percent max heart rate, which if we're talking about endurance-related sports, that needs to be really, really clear, but still should be clear for just about any sport. Honestly, for strength training, you're doing push-ups. I don't know what your heart rate is. What's your percent heart rate expectation? That's important. Because, of course, if the heart rate's rising up significantly, you're going to be seeing more and more probability the person's not going to perform as well. So we want to make sure we understand that and be clear about that. RPE, you should always have a goal RPE, meaning what's my expectation on a scale of 1 to 10, how hard this set is for my athlete or athletes. I'm expecting it's a 7, it's a 6, it's an 8, it's a 9. And it's relative to what you're expecting for the output, right? You're thinking that, well, if I said it's 90% effort, then I'm going to expect the heart rate somewhere in that general range and that probably the RPE is somewhere in that general range. Well, that's not an unfair expectation, but remember what we want, what all of us want, and we know this, but I just don't think we really thought about, in many cases, for many of you before you came to this class, as I posed it to you, is the idea that do you really want RPE to be high, or do you really want more than anything else the force output? How fast they're moving, how efficiently they're moving on top of how fast they're moving, how much weight are they moving, how much power are they exerting, are they knocking people over if it's in football and they're blocking a guy or trying to get through the line to the quarterback, or if we're talking about hockey, what's the velocity in which they're hitting the puck, soccer, of course how fast they're able to move, their agility, of course, change of direction and control, but certainly how fast they get on the field of the faster team. That's force output. Okay, RPE ideally would be low, because if RPE is low and heart rate are low, and then the force output's high, that team is going to be the ones not going to be fatigued at all as the game goes on. So that is the goal. It doesn't mean the heart rate can't be up, doesn't mean the RPE can't be up. But when I keep asking the same questions that we're now in week 6, you need to start saying to me the primary goal is performance, because that needs to be what it is. There's no way around that simple response. It's performance. That's the goal. When I say I want high intensity, I want high performance. I don't want high heart rate and low performance. That makes no sense. That's what we want, right? And number of sets, as soon as you start talking about things like 10 sets or more, a couple of you in your posts talked about doing things that were fairly high intensity for 10 sets or more. You got to really check yourself on that one there. Why do I say that? Not because you're wrong, because if you have really high level athletes, they might be able to do that. If you're doing 20, 30 seconds work and 60 seconds or less rest and doing 10 sets or more, there's a good bet performance is going to wane significantly. Or here's the big thing. When anyone understands there's a lot of sets coming, what everyone does is they conserve their energy. I remember doing it. We ran line sprints in football or in basketball, where they told us one day we're coming to track, we're doing 8 400s rather than 4 400s, but I knew what I was going to do. I didn't say off the top of my head I'm going to go slower, but I knew, of course, I was going to go a little slower. I wasn't going to try to push as hard if I'm doing that many. They will conserve. So you got to make sure you're really clear about the expectation of goals. Make sure it's a fair expectation of number of sets. I wouldn't start with 10. I'd start with 3 or 4 and build upward from there before they can actually try to accomplish quite so many. Cardiac output. The two primary components of cardiac output are heart rate and stroke volume. Perfect world, heart rate's not too terribly high, and stroke volume is. That's what you really want. That's where you're going to get the most ideal performances, where the person who's actually engaged in activity has a high stroke volume, meaning a high expulsion of blood coming out of that heart, right? The ventricles of the heart. Oxygenated blood, nutrient-rich blood. Many of you said oxygen-rich blood, and I kept asking many of you in the post from this last week, what else besides oxygen? Nutrients, right? We're talking about the nutrients in order to produce ATP, right? Not just oxygen itself. Perfect world, cardiac output is high because stroke volume is high, but heart rate is low. But you have a high cardiac output because of that high stroke volume. That's what I was getting at for many of you when you said heart rate goes up. And I said, okay, perfect world though, if heart rate's not going up, but performance is. Why is that? Because stroke volume is high. If the person is engaging high level activity, they start to fatigue and have difficulty, and the heart rate starts going up, what's happening? The stroke volume becomes limited. They're getting low stroke volume, and the way the heart compensates for that is to increase the heart rate. And that's what we're looking at. And that's why it's our indicator that heart rate going up is not necessarily a good thing. And that's why. Heart rate variability differences. A lot of you had some confusion with heart rate variability. I thought I made it clear in my last week's video post, but maybe I didn't. But you're actually at rest. Your heart rate variability, perfect world, is going to be high. Your body's responding to every cellular response quite adequately, quite quickly, then returns back to normal, but then jumps again the next opportunity. It responds fast, returns back to normal fast. So you see variability in the timing between beats. There's significant changes in timing between beats. It's not a consistent metronomic deep, deep, deep heart rate, okay? Whereas someone who's out of shape is going to see a higher resting heart rate, but limited variability, generally speaking. And when they both engage in higher intensity or more moderate to higher intensity activity, the person who is a fit person is going to see less variability in their heart rate. And of course, a couple of you said it, but I want to make sure you were clear about it. It's only when that person who is well-conditioned starts to become fatigued as the session goes on that you start to see more and more variability at higher levels of intensity. You should not see higher levels of variability at higher intensities unless you're okay with the fact that performance is starting to wane or they're starting to become challenged, they're down to their last set or two, or they're done, one of the two. Okay. And that said, heart rate and homeostasis. You want that body to return back to normalized heart rate as close to the resting heart rate as possible when they finish their training session. Now, it's highly unlikely any human being is going to come back to their resting heart rate after a significant training session. But the closer you can get to that, the faster that body's going to be able to return to homeostasis, to avoid the venous pooling, to return oxygen and nutrient flow back to the muscles that were being used, to get proper circulation throughout the body as a whole, to bring the body back to a limited level whereby hormonally the body is responding normally again, like a fight or flight concept of a lion is coming to get the zebra knows it. This is exercise, right? The lion comes, zebra's got to run. That's the exercise set. And then ideally what should happen, theoretically, zebra doesn't have to run terribly long. It's not going to be able to. It's going to be gone, right? And the lion goes away, and that zebra's stress comes back to normal very, very quickly because, hey, the lion's gone. What do I got to worry about? Whereas what happens when people engage in too high of intensity too often or for too long a periods, then what happens is you're always, that zebra's on all the time. That individual athlete has all these high cortisol levels, all this hormonal imbalance, higher heart rate, not feeling good, all those things, feeling of fatigue because of all this continual negative catabolic effects going on internally that are limiting the person's recovery, limiting the return to homeostasis, and that's not what we want. And then as far as VO2 max, your aerobic capacity and versus your maximum heart rate, Now, as we get closer and closer to that 95+% VO2 max and 95+% maximum heart rate, yeah, you're going to find they're going to be pretty consistent. But for the most part, when we say VO2 max or aerobic capacity percentage-wise, it's going to be lower than the max heart rate, up to about the 90+%, where you start to see it more leveling out, being consistent between the two. Okay. As a matter of fact, one of the most common numbers that's really big, as we mentioned in the text, is really important, and I said it, I think, last week's video, that 40% VO2 max level intensity for recovery is ideal. For your cool down, be sub 40% VO2 max, which means sub 60-ish, 63% by some calculations, sub 60% max heart rate during your cool down or during recovery day. Anything you're supposed to be recovering from or supposed to be getting recovery time, make sure it's lower than that intensity. And again, set your heart rate maximums. Don't set minimums. Please don't do that, because it's not consistent with performance. And of course, RPE, as we mentioned again, better be low, probably level 3 or 4 for a cool down. It's supposed to be something easy. Force output, we got to be clear about, if it's a cool down, it's low force output. Warming up starts light and increases. Don't let people get carried away with going high intensity effort-wise with the warming up and the cooling down. That's not the intent. Save it for the session. I want to see it in the session itself, not the warm up with the cool down. Otherwise, we're going to see fatigue earlier, and that's definitely not the goal, right? And of course, we gave you a formula here, and if you don't see me post it for you, versus you having to type it in here and I can't copy and paste it necessarily from the PowerPoint video when you're watching a video on YouTube, I will post it so you actually have it. But if you Google literally VO2 max to max heart rate or max heart rate to VO2 max calculator in Google, you'll get this website. You can go in there and you can actually enter in a value, and it'll give you a percent relativity between max heart rate and VO2 max. So we know what we're talking about relatively when we talk about relative expectations for our internal response. Okay, external response is what we want, right? Force output. But we really want the right intensity versus high intensity, moderate intensity, or low intensity. Whenever you talk about high intensity, low intensity, moderate intensity, you're going to explain why it's the right intensity at this moment. And never is it good to start with high. You start with low and move up toward high on a given day, let alone during the course of the week. All right? We don't do high intensity every day. Show me a high intensity athlete who trains high intensity all the time, and I'll show you either a liar or I'll show you an athlete who frequently gets hurt, frequently gets sick, and is not the best athlete in the world. Or they're absolute freak. And we mean that in a good way. Someone who just is a freak in nature and they can do things that no other people can. Otherwise, you got to have that balance of the moderate and low intensity beyond the high intensity type work. Now, let's move into week 6. Acid-base balance and hydrogen ions. Generally speaking, the body's pH is somewhere around 7.4, and that scale is 0 to 14. Slightly towards an alkaline. Below 7 goes more toward acid, right? And of course, it's a slight variance, as your book mentions, about 0.05 for most people. It's not a very wide variance. About 7.4 is about ideal. As you start engaging in significantly stressful exercise, pH will typically drop. Okay, start getting the excess hydrogen ion accumulation, and those excess hydrogen ions try to bind with troponin at the muscular, basically at the muscle, whereby it makes it harder for ATP to bind, and actually for you to get muscular contraction. That's one of the reasons why you have a hard time not dealing with fatigue and getting proper muscular contraction, because those hydrogen ions are trying to bond in the places where you're trying to get ATP to bind with troponin to be able to get that muscular contraction and to get that actin myosin cross bridging for the cross filament response, whereby you get muscular contraction effectively. Okay, that said, to manage that, well, once again, we have to find that right intensity, the right work period, the right rest period, all those factors, which is never an easy thing. But that's what you're seeing, essentially, when someone's having difficulty coping with the stress as we go on set per set, or as the intensity increases in a given set or in a given performance. And of course, the acidosis potential effects, well, someone can get fatigue, is the obvious, but also mental fatigue, confusion. That's extreme. That person's have a real hard time coping with current stress. That's something we really want to pay attention to. When your athletes you find are not able to pay attention to you, they feel like, look, they're zoning out, maybe you're putting too much stress on them right now. And it may not be because the stress you decided that it was wrong, it's just wrong for them in this moment. It's something to really, really think about. How important is it to push hard if the response is not going to be what we want it to be? Right? We feel sometimes we get mad because our athletes aren't ready for us. Like, why'd you not come ready today? Why'd you not get rested? Why'd you not take care of yourself? The fact is they didn't. So what you want to do is to get in the lower intensity, then get after them after the session, say, if you come with me tomorrow like this, you're not playing, or I'm going to put so-and-so on your spot, or you know, you got to show me better response if you're going to actually expect to get better performance out of this. If you want to get a PR this week, if you want to want to win more games, whatever it is, you got to give them that important mental boost as well, right? But don't push them if the response is low. It's such a common thing in our field to punish people not performing well. And if they're physically not able to do it, they're physically not able to do it, whatever reason that might be, right? And of course, the acidosis' potential effects, well, it's going to be an ongoing thing if we don't deal with that stress in the short term. How do we deal with it? Give longer rests, lower the intensity. Not rocket science. However, it's something we have to really be paying attention to. That's why we have to mark more things. We have to be clear about what speed over what distance. Using stopwatches more, using timers more. If you don't want to do it because you're a coach, have someone else do it. To be clear about how long it took someone to get up and down the court, how long it took someone to change directions and get around the defender, whatever the heck it was you're looking at. Make sure you have clear parameters so you know what you're measuring, so you actually have an idea if someone's improving or not. Okay? And of course, buffers. Your body has all sorts of internal buffers with carnosine, with histidine, with phosphates, all sorts of responses internally to deal with the buffering, the natural response of actually helping the body. Fast twitch muscle fibers have a higher buffering capacity than slow twitch muscle fibers. However, they also have a limited life for what they can give you powerful output or high force output. That's one of the reasons why slow twitch muscle fibers can go for longer periods. They don't need to have a high buffering capacity. The fast twitch muscle fibers need the high buffering capacity, or they couldn't give you that output for short bursts, and that's why. Now, some people go so far as taking like baking soda, ingesting it, and other forms of phosphate to be able to take in, to actually ingest, to help increase that time towards acidosis, so they actually perform for longer before the acidosis sets in and creates that fatigue challenge. That's been shown to have some positive effects for the person who's ready to take those kinds of things, but not really something we want to experiment a whole lot with until you're sure your athlete's already got the right training, the right focus, the right preparation, eating well, resting well. Then we talk about those things. But those are all possibilities down the road, for sure. Okay. Now, blood flow with hot and cold environments. Blood's going to flow to the skin, more specifically when it's hot out, trying to cool the skin layer, right? Sweating and consequently and whatnot, you'll get that very clammy, wet skin because your body is trying to sweat more because it's interpreting this to be too hot. And of course, one of the reasons why some people's skin gets so cold so fast in colder environments is because now the blood's rushing internally, sensing this is too cold, let's rush to protect the internal tissues, and so the skin's left exposed and getting colder. You'll see some people, a lot of times people who get hotter first can also be some of the people that actually can get, their skin will get cold, they won't feel cold, but the skin will get cold. Okay? If people who are used to cold environments, their skin may be cold, but they feel fine, because their body is effectively warming internally. Don't confuse with your skin is cold with you must be terribly cold. It's not necessarily true. Okay? It has to do with a lot more in-depth response going on internally that's affecting this. And in situations where we have hypothermia, or extreme cold, we can avoid this by, of course, layering our clothes, by drinking more water. Your textbook talks about 150 to 300 milliliters every 20 minutes. I think an easier one is really 6 to 8 ounces every 10 to 15 minutes, but it's not far off from those same numbers. We often use the 6 to 8 ounces every 10 to 15 minutes. The textbook refers to that 150 to 300 milliliters for every 20 minutes. Okay, do at least either of those, at least. Okay, whether it's hot or cold, either extreme. Okay, but for the hypothermia issue, the water, layering clothes, taking them off, it gets warmer. The body gets warmer throughout the course of activity. The lengthening of the warm up should be occurring. The lengthening of the cool down. You can't make it shorter in colder environments. Hotter environments, you're going to shorten the warm up. You're going to shorten the cool down. Just the opposite, because you're going to expect I'm going to wear this person out too fast, as opposed to needing more time to warm them up, more time to cool them down in colder environments. In situations with hyperthermia, where we have someone have potential of heat stroke or heat exhaustion kicks in first, whereby the body starts they're sweating profusely. Okay, and they're like looking whitish and clammy, and they're a little bit confused. The person needs to get done with the activity, drink a ton of water, and get out of the heat, get into cool. You're done for the day. Okay, heat stroke is much more severe. If your athlete's getting to this, someone's not paying attention. Happens all the time in doubles with football, in college and high school. Hopefully not as much high school, but certainly in college. When there's all these athletes and not enough coaches are not paying attention, drives me nuts. They get too caught up in high intensity rather than taking care of people. No one should pass out in your sport. No one should be throwing up in your sport during the practice. That shouldn't be happening. That's on you. I don't care what they did. That's our job to make sure they don't do that. And then we take care of some other punishment where they can't play or have something else going on. You don't punish them with physical activity. That's not doing any good for anybody. They're not getting better because of that. Okay. That said, That's just an ego thing for ourselves. We've all done it as coaches. We have that person you want to teach them a lesson, and it's not a good thing. It's never a good thing. But the person the more severe, their skin is red. They're not sweating, and they have difficulty even standing, possibly fainting. They might even faint on you. That's a emergency call, 911. That person needs an ice bath. Get them out of the heat. Get them completely done right now. Putting wet towels all over them and get paramedics to come and help this person out. If you don't wet towels, if you don't have ice, right? But get them into an extremely cold environment as fast as possible and get someone to help as soon as possible to take this person to the hospital, because that's life-threatening stuff. Your body varies in temperature up to 113 degrees, that's probably going to be it for you. If it drops down to 92 or below, it's probably going to be it for you. Those are our ranges that we don't want to see someone drop below. We're probably not going to see that. That would be pretty extreme. But those are the situations where your body can't cope with those extremes in temperature cool or temperature hot. Okay? That said, we talked about water intake, weight loss. If someone lost a pound, expect to drink 1.5 to 2 pounds of water to replace what you lost during the session. Okay? And coping with those extremes, you want to make sure you're constantly asking your athletes in extreme situations they're not used to and trying to get them acclimated to the activity. How are you feeling? Don't let them be tough. We don't need that. We like tough athletes, but we also want honest athletes. Be tough and deal with it, but tell me if it's hard. I want them to tell me, this is hard, coach, but I'm going to do it again, though. That's all I want to hear them say. No, I'm fine. It's a piece of cake. No, don't tell me it's a piece of cake. I can tell you it's not a piece of cake. It's obvious watching your performance. You're getting worse. That's funny. You told me it's a piece of cake. You're getting worse. You're either a liar or you have no idea how your body's working right now, which means either way, we need to lower the intensity, regardless. Okay? Get them to be honest with you. We don't want them to try to act tough. Be tough as far as how you play, how hard you work, but tell me honestly, how are you feeling, how this is going? You have to make sure you ask enough times, give a lot of feedback back and forth through athletes for you to get a lot of honest response here, because they're going to feel like they're being weak when they tell you things like that. You want to make sure they understand that's not what this is. This is about appropriate feedback to know what's appropriate for you. They'll know when to push you and when to back off. Okay? And of course, final thoughts now as we go into our 6th week. Whenever you talk in your discussion boards about any particular concept, please don't say so-and-so said. Don't ever say so-and-so said. I don't care if it's me or anyone else. We don't want to hear about what some other guru says. We want to hear about the research and the science. We want to hear you citing some study and actually giving some feedback on it, but don't say who wrote the book. Don't talk about anything like that. A couple of you have done that. I got after you about that. I'm going to keep getting after you about that. I do it too sometimes. I catch myself doing it. We don't cite a person. We actually cite the information. And we also want to be very, very careful about doing what all of us tend to do, including me, which is to defend your position. Don't defend, just be clear about, well, maybe someone poses an idea that maybe, hey, maybe that's a good idea. Maybe I should take a closer look at what I'm doing. This is the environment, as a class environment, where you can do that. It's a lot harder when you're the coach. If an athlete questions you, that's a problem. I'm questioning you because I want you to have a lot of clarity in what you do with your athletes so you can maximize the performance and make sure you're getting the most out of them without overdoing it or, underdoing it. When it comes to push comes to shove, though, it's better off you underdo it a little bit. You can always adapt that much easier. When you overdo it, it's a lot harder to change things after you've overdone something. Okay? But please don't say about what so-and-so said, or I even read what the book said. Don't do that. Make sure you cite the information specifically. Okay? And of course, citation consistency is the key. Many of you are still not attaching that PDF and using that APA format. Specifically look at that link that's actually in the very first page in Blackboard that says, look, check here for Purdue's website for the OWL for their APA format, so you know how to cite at the end of each research discussion board post you make. Make sure you have at least one article. You never can be hurting by having more than one, and have whichever one is your primary one you're going to be using, make sure you attach it in PDF form. Okay, and preferably you attach all of them, really, because we want to be able to read and find out if you're using anything where you're citing it in your discussion board post. You gotta attach it. I want to be able to click on it and find what you were saying somewhere in that post very quickly, let alone your peers, and you'd be able to do that. I know it's a pain. Is it important? Yes. Is it necessary? Yes. Is it something that's annoying? Yes. You still have to do it. There's no question about it. I will tell you flat out, one of the criticisms I've gotten the most often from my peers toward with my classes is they want to see more of the APA format. They want everything more clarity. That's the heat that I get from other people about making sure everything is clear with you. And at first, my response was, my first time was, come on, is that really unimportant? Yes, it is. It's not exactly easy to do. It takes a lot of time to do. Once you get the hang of it, it's not that hard, but you got to do it. And I'm going to keep taking away points from you if you don't cite it, if you don't attach it in PDF form, or give me a clickable link that I can click on it and see the article right away. doing well. And if you have concerns, and many of you have, always email me your concerns. That's good. I want to hear from you. If I don't hear anything from you, I assume everything's great. I don't assume things are bad. So tell me if they're not good, and we'll do what we can to help you out any way that we can. Keep working hard, keep after it, and I'll talk to you again soon.